When you first look at this, it probably seems like some kind of secret code or maybe a really weird puzzle. And you know what? In a way, it is. This is a simple program written in C, which is one of the most important programming languages out there. But what if I told you that by the end of this quick explainer, you'll know exactly what this code is doing and even how it works? So let's jump right in. We're going to decode the basics of C together. Our mission is to take that mysterious-looking text and just pull it apart piece by piece so you can see the simple logic that's hiding in plain sight. Okay, first things first, you might be wondering, how does the text we write, what programmers call source code, actually become a program that a computer can run? I promise it isn't magic. It's actually a pretty incredible journey. What you're looking at here is basically the entire life story of a C program. It starts out as just a simple text file that we can read, but then it goes through this whole transformation process. This is called compilation, and it's all about turning our human-friendly ideas into raw machine instructions that a computer's brain, its processor, can understand instantly. That's what makes C so incredibly fast and powerful. Now, that whole cycle might look a little complicated, but you can really just think of it like a factory's assembly line. First, we write the code. Then, a tool called a compiler translates it into the computer's native language. After that, a linker comes along and bundles in any extra tools we need. And finally, the finished program gets loaded into memory so it can run. It's a really efficient process that takes our thoughts and turns them into actions. All right, now that we know how the code gets from point A to point B, let's circle back to our original code snippet. We're going to do a little dissection, you could say. Take a look at its fundamental structure, its skeleton. Believe it or not, pretty much every C program you'll ever see is built on this same basic skeleton. You can think of it like a blueprint. There are these core components, like header files and the main function, and they are the non-negotiable parts that form the foundation for everything else. So what's up with that very first line, the one with the hashtag include? The best way to think about it is like grabbing a toolkit before you start a job. You're telling the program, hey, I'm going to need some standard tools for things like printing stuff to the screen. Including this header file gives you access to all these pre-built functions so you don't have to create them from scratch. Next up is int main. Now this is the big one. This is the absolute heart of the program, the main entrance. No matter how huge or complex your code gets, the computer always looks for main first. It's the official starting line where everything kicks off. Every single C program has to have one. And what about those curly braces? They're really just containers. The opening brace says, okay, the instructions for the main function start right here. And the closing brace says, and they end right here. Anything and everything between those two braces belong to that main function. Okay, so we've got the skeleton down, but what about the actual stuff inside it? You see, to a computer, the number 5 and the letter A are completely different beasts. The program has to know what kind of information it's dealing with, and that's where data types come in. C sorts data into a few different buckets, but the most important ones, especially when you're starting out, are the primitive types. Think of these as the absolute rock-bottom building blocks of information, things like whole numbers, numbers with decimals, and single letters. Let's break down the most common ones. A char just holds a single character. An int is for a whole number, no decimals allowed. And a float, that's for a number that does have a decimal point. And hey, look at that. If you remember our original code, we used float for pi. That was us telling the computer, hey, this number is going to have a decimal point, so be ready for it. Okay, so we know about the different types of data, but how do we actually, store that information and give it a name inside our program? Well, that's where variables and constants come into play. When we create things in C, we have to give them names. We call these names identifiers, and you can get pretty creative. My age, top score, whatever you want, as long as you follow a couple of simple rules. But, and this is a big but, there are certain words you just can't use. These are called keywords. Special reserved words like int or if that already have a special job in the C language itself. So data gets stored in two main ways. A variable is like a cardboard box you can open and close. You can put something in it, take it out, and put something else in later. It's changeable. But a constant, that's like a box that's been sealed shut with superglue. Once you put a value in there, it's locked in for good. And aha, this brings us right back to where we started. Remember that line from our code?
const float pi equals 3.14, that is exactly what we were doing. We were creating a sealed box, naming it pi, putting the decimal number 3.14 inside, and telling the computer that this value can never, ever be changed.
Okay, we've got our structure, we've got our data stored away, but a program that doesn't do anything is pretty boring, right? So how do we actually make things happen, perform actions, and communicate with the world? This is all about input and output, or I/O. For showing stuff on the screen, the most common tool is printfr. And yep, if you look back at our program, that line that says printfr, the value of pi is, that's its whole job. It's taking our result and displaying it on the screen so we can actually read it. Now, to perform actions like math, we use things called operators. These are just the symbols you already know, like plus, minus, equals, and so on. They are the action verbs of the programming world, telling the computer what to actually do. All right, let's have a little fun with this. Time for a pop quiz. In all the math you've ever done in school, 5 divided by 2 is 2.5, right? Simple. But what do you think a C program says the answer is? Okay, you ready for this? The answer is do. Just do. Weird, right? Well, here's why. In C, when you divide a whole number, an integer, by another whole number, the result has to be a whole number too. So the computer just chops off the decimal part. As you can see here, if you actually want to get 2.5, at least one of your numbers has to be a decimal type, like 5.0 divided by 2. And this right here is the whole point. This is why those data types we talked about are so important. They aren't just for keeping things organized, they fundamentally change how the program works. That simple choice between an int and a float can literally change the answer you get from your math. The details really matter. So there you have it. We've cracked the code. We've seen the skeleton, the data types, and the actions. It all just boils down to a set of simple building blocks for giving a computer a list of instructions. So now that you know the basics, the only real question left is, what instructions would you want to give it?